Okay, talking about the first synthesizer here available to us, KTERM, that stands for Komplexer Terminal. MATHIAS wrote this program for his own use, much in the same way as Waveterm was made for the PPG. I've done a bit of homework today and discovered a few things about the inner workings of the KTERM synthesizer here. And I always saw this right here, it says sine waves, and I said, what does that mean? I never realized until today. I'm going to show you a couple of references here. The the sound is processed internally by KTERM on a sine wave basis. It's an additive synthesizer. It does not handle actual wave data. It reads wave data coming in. It resynthesizes it into sine waves, 64 to be exact. Does its processing thing, and then it renders out a wave file of one sort or another. Alright, I'm going to show you a couple of notes here. That's not it. Okay, these are MATHIAS's own words. I've got this off the KVR forum. KTERM is a kind of simple emulation of the additive part of the Komplexer engine. Alright, we're going to read a little bit out of the Komplexer manual in a moment. KTERM is an additive synth. 33 slots with 64 bipolar sine partials each. So it's a 64 partial additive synthesizer, and there are 33 slots that can hold actual wave data, but it's always resynthesized into additive harmonic information before it's processed. And once again, it's an emulation of the Teratech Komplexer wavetable oscillator. All other formats are derived from that model. In other words, all processing is done with 33 slots of wave data that are translated into a 64 sine wave additive expression of audio. Let's look at the Komplexer manual. This is, I'll just read it. A wavetable consists of 33 waveforms that are smoothly superimposed in real time, aka resynthesized. While older Waldorf synthesizers and the PPG changed waveforms in hard steps. Alright, this is a distinction between PPG voice and Audioterm. And it comes with its own advantages and disadvantages, but we're going to view it all as positive here. It's something different. This part here doesn't really pertain to us too much. That's it. So there we've got a little bit of, I don't know what's going on here. We've got a little bit of theory behind us now. So once again, KTERM, or Komplexer Terminal, is an additive synthesizer that works with sine waves only. Okay, let's go in. I've already discussed the operation of the disk button and also the viewer button, and later on we'll use them some more, but there's no need for me to review them right now. We're going to cover the slice button. Alright, here we have the 64, numbered 0 to 63. Bipolar, up and down, plus and minus, harmonics. You may want to give yourself a primer on harmonic synthesis, or additive synthesis rather, on YouTube. I don't have a specific link for you, or maybe Wiki has a good entry on additive synthesis. They probably do. Basically how sound can be composed at its most basic level by sine waves. Or to say it another way, all sound can be reduced to sine waves. Alright, right here we've got 33 slices, and they are represented here. Okay, and I can navigate through them one by one right and one left, or I can skip 8. Let's go to the right one. Okay, I just went to the right. Let me go right 8. Okay. I'm going to go back to the first one. It's called slice 0. Why do they skip? I'm jumping ahead a little bit, but if you look up here, see how I'm moving across here? Sometimes it's practical to create a wavetable and define it only with, as you saw, 5 slices and allow the interpolation algorithm to generate the in-between ones. Because, well, I'm not going to try to answer the why, but it'll become evident in the future. It just becomes a question of practicality. You don't always need to define each little slice to come up with a musically usable wavetable. And sometimes it's not even desired. Sometimes you may only define the first and the last slice and let interpolation do it all. Alright. What else can we talk about? We've got 33 empty slices, little rectangles. Filled slices, if I alter the data in one, then that particular one will add up here. It'll start counting upwards. Current slice, we're on slice 0. Slice content is empty. So slice 0 is empty because I haven't touched anything yet. Now the partials, I wish that there was a word right here that said partial. I think that that's an oversight. That's all my opinion. But anyway, just so you know, these are the partials. 0 to 63, there's 64 of them. And the partial value expressed positive or negative. Okay? This is a waveform display. This is like an oscilloscope, or when we talk about sawtooth waves, square waves, that's what we're used to seeing up here, our sine wave. That's what we're used to. That's how most of us are used to seeing audio. However, down here we're expressing it harmonically or additively. And I've got all 64 of these partials, and I can specify how loud they are, and all this is only in reference to slice 0, the first slice. So the next one, I will have a blank page again, and I'll define that one. I'm going to give you a little bit of, I'm going to let you cheat a little bit for those of you that don't know anything about additive. And we're going to make a sine wave. And a sine wave is one single harmonic. And it's the first one. Okay? So a sine wave is the most basic sound you can have. And I'll just keep it limited, but that's how you create it. I just created a sine wave. We're going to find out in just a minute which harmonics are used to create a sawtooth wave and which harmonics are used to create a square wave. And you're going to have an aha moment here if you haven't had it yet in your study of synthesizer, about why those were chosen. There's a very conspicuous reason why they were used in all the old Moogs and everything on up through. And we're going to see it right now. Okay. I've covered these 4 buttons here, the navigation, covered the waveform display, and a bit of the harmonic display here. Wave draw. See, I can't do it. I can't affect this right here. I can only affect the waveform by specifying harmonic values. But in here, it's nice. MATHIAS added this feature, which is great. It allows me to actually draw a waveform, and then I can come back and see what harmonics were used to generate it. So let's clear this out and use the undo button. Let's go to Wave Draw. Okay. Here it comes into focus once again. I will draw something here, and then it has to go through the resynthesis internal engine of Audioterm, and it will be expressed up here. We'll have a visual representation up here of how Audioterm has resynthesized it, and it is expressing it in terms of sine waves being added together. Okay? First, I'm going to draw, what shall we do here? I'm going to draw a square wave. I'm going to go up like this,